We're going to common factor some expressions. In this expression, we have two terms, 6x and 15. They are both divisible by 3. Therefore, we can common factor out a 3. In this expression, each of the terms can have an x factored out of it, like that. In this expression, we can factor out a 2x. In this case, we can factor out a negative 6x. So if we want to check our work, we can take the negative 6x, multiply it by the 2x. Negative 6 times positive 2 makes negative 12. X times x makes x squared. And we could do the same thing for this term. Here we have two fractions being multiplied. We're going to simplify this expression. When we're multiplying fractions, we multiply the numerators and we multiply the denominators. Let's divide two fractions. When we're dividing two fractions, that's the same as multiplying by the reciprocal. And just like we did in the previous question, multiply the numerators and the denominators. Sometimes when we're multiplying two fractions, we can simplify along the way. And so we know that we're going to have a 6 divided by 3 when we finish multiplying this. So even before we do that multiplication, we can replace the 6 with a 2 and the 3 with a 1. And if we divide the 15 by 5 and the 10 by 5, we get 3 and 2. So 2 times 2 is 4, 3 times 1 is 3. If we had done this the long way, we would have got 60 over 45. And then we would have divided the numerator by 15 and the denominator by 15 to get 4/3. Here we are dividing. We're going to multiply by the reciprocal. Now that we have two fractions being multiplied, we can do our simplifying process. We get 2 here and 3 here. If we divide the 8 and 12 by 4, we get 2 times 5, 3 times 3. Same or similar situation here. We've got a 12x and an 8x. That means we can divide both of those terms by 4x, leaving us with 3. And 2. So we're going to multiply by the reciprocal. And we can divide the 6 and the 3 by 3, leaving 2 and 1. We can divide the 2x and the 8x by 2x. So that's going to leave us with a 1 here and a 4 here. Here we have a slightly more complex expression, and we see that there are factors of x plus 1 in this numerator and in this denominator. We can divide both of those factors out, leaving us with 3 times 6 and 8 times 1, which is 18 over 8, or 9 over 4. Okay, so we're doing division here. And we notice, if we look carefully, that this can be common factored. Well, how does that help us? Well, we have a factor of x minus 3 here and a factor of x minus 3 here. We can divide the numerator by x minus 3 and the denominator by x minus 3, simplifying to 10 over 3. Okay, so I see an expression here that looks like it could be factored, so I'm going to try and factor it. And it looks like I can simplify this expression to 5/3. So we're going to start here by factoring 3x, negative 3x. And we can divide out the x minus 5 terms and the x plus 1 terms, leaving negative 6x. So state the restrictions on these examples. So here is an example that has been simplified. We want to state the restrictions on the variable x. Restrictions are basically what x cannot be equal to. So in this case, x can be any real number, so there are no restrictions. In this example, we've simplified it, and we can see that x cannot be equal to 0, because if x were equal to 0, this would be undefined. This quotient, this rational number, and for that reason, x cannot be 0 at this stage, or any of the lines. So in this example, we've simplified it. We can see that the two x terms were divided out, and we are left with 3 over x minus 5. So if x was 0, then this expression would be undefined because it would be 3 divided by 0. So x cannot equal 0. If x were 5, it would also be undefined because it would be 5 divided by 0. So those are the restrictions on x. In this example, x cannot be equal to 1. And that's because it would make this expression undefined. It would also make this expression undefined. So even though there is no x in this expression, the restriction is that x cannot be equal to 1.